Hi guys, welcome back. Sorry it's been quite a while since I've done a video on Exodus. I've just been started a new job and moving house, or well, moving places. So this is my new office, different background, it's not quite as cramped, I can actually put my arms out like that, which is nice. Yeah, so what I've been working on is the navigation, so flying ships and fleets around the the world map, and I kind of got stuck on it because it's actually a really big complex thing, and I kind of got bogged down in faffing around and really haven't made much progress. So what I've decided to do is start again from the basics. I made a small scene yesterday, and what I'm going to do is I'm going to start with just changing the ship's orbit from one orbit around the planet to another, and then we're going to go from there and gradually expand the system. So I'm just going to make sure that this encoded properly, because I've been having some video encoding issues the last couple of days, and if it has, we will carry on and I will explain what the plan is. Okay, yeah, like there's ever a plan. Sorry, I got a bit of a frog in my throat this morning, so I'm going to be coughing and spluttering and whatever. Okay, so here we are in Inkscape, and we've got a little ship, we've got a planet, which is incredibly small, we've got the current orbit the ship's on and a new orbit. And the process we're going to have is you right click to bring up the context menu on something you want to navigate to, select move, and then drag out a new orbit. So that's going to be how the UI works. The navigator, which is what I want to work on in this video, is just going to work out how to plot a course from one orbit to another. Now, for the time being, this is just going to be circular orbits that you can set fleets on. Later on, we'll probably set it up so that you can move between inclinations and eccentricities, although I'm not sure what the what use moving between eccentricities would be in the gameplay. I don't know. People might find an interesting thing, but we'll do that later on. Right now, from one flat circular orbit to another. So the process I'm going to go through, and I just realised I left my notebook on the porch where I was planning this, is we're going to work out the angle from the ship to the planet as a vector. So this is the vector from the orbit centre, the planet, to the ship, and then what we're going to do is invert that to get a point on the goal orbit that is the opposite side. So we've now got this goal point here, which is where the ship is going to go to. So we're going to end up there. So the next step we're going to do is, so that's one. Two, we're going to work out a perpendicular angle in the direction of flight, and then we're going to make another vector there. And this is going to be half the distance, or half the difference in the radius of the orbits, so that it's the halfway point. Then we're going to go and create a nav path, which you can see in the other videos that are quite early on in the project, and then that's going to be smoothed, or rather smoothed, with the handles, and so the navigation does work by a Bezier spline, so it will look approximately like this. I found going about halfway on each kind of works. I can't remember what the exact settings were. So what we're going to end up finally is an orbit that looks like this. Which is not quite right now that I look at it. And the reason being is, oops, it needs to actually be an ellipse. So this needs to be halfway from there to there. Okay. So I had actually worked that out wrong. I'm glad I redrew this. Right. So this point here, where we create the other vector, needs to be halfway between where the ships will end up, not actually at the orbit centre. And then the plan is the ship follows this new nav path round, gets to its new orbit, and then it sets up its nav path as the orbit. That's the plan, as it is. So we're going to jump into code now. I might be going out in a second, so I'll probably record the code stuff later on. Yeah, so we'll jump into a bit of fast forward code, and then I will explain what's happened, and hopefully we'll actually see this working in the game. So what we got here is we got our two orbits in green. Our starting orbit is the inner one, and the ending orbit is the outer one. The little cube is the ship. The sphere is the planet, obviously. And then the black line is the calculated transfer path between the orbits. So what we're doing is, from this part of the orbit here, the ship will accelerate, fall on this orbit path, and then decelerate into the target orbit. Or, sorry, accelerate to push it up. Obviously it's not using any Newtonian physics here. This is all like on rails, because all the movement in the game is on rails. It's kind of like faked. So at the moment, the way this is being calculated is we're just using the X and the Y axes, or the X and the Z axis rather, in Unity, to basically simplify everything. So I'm basically creating this path using units of 1 and then scaling it to actually fit it between the two. What I need to add, and I've been thinking about this over the last couple of days, is we want to transfer from here and we want to get to there, or we have an object here and we want to transfer at a point where we will meet it there. So what I need to be able to do is, rather, at the moment the position of stuff along its orbit is just done with delta time with just a multiplier, which is based on the orbit radius. That's kind of a very, very rough approximation of like how it works with orbit radius and the orbit period. What I need to be able to do is instead convert that into something where I can say at this time what is the position of the object, and then what I can then do is for the live updates of all the objects moving around, I can say where's the object now. But if I plot a transfer to another object, I can then calculate how long that transfer is going to take, and then say where is that object going to be at that time, and then shift the transfer around so that it will go so that by the time the ship reaches target orbit, it will meet up with the other object. So that's what I want to work on next. But getting the sort of the rough paths drawn out is working so far. So what I'm going to do is I'm just going to quickly go in and tweak the orbit settings, because I'm interested to see how well this works with like inclined orbits just as it is. I'm pretty sure it won't. So if you give me a moment, I'll do that and then we'll come back. Okay, so what I've done is I've changed the eccentricity of the target orbit to 0.3-ish, and then rerun the calculation, and you can see while it's getting the correct point on it, it's obviously not as well aligned as it could be. So what I need to do next is implement the position at a time function, and then look at this needs to be aligned with various things. I'm wondering, to do that we'd probably want to take work out the cross by taking the position 180 degrees around the orbit. We'd then want to go 90 degrees around the orbit and get the sort of the midpoint, because obviously that midpoint should be about here, and then plot the course there, because this would be quite an odd, you wouldn't probably do this transfer in real life, I'd guess, because it's quite a high energy one, because what you'd want to do is you'd want to end up here accelerating that way, so you'd want to be speeding up to catch up. In the game, the ships are all powered by like magic space drive, so apart from that sort of maneuver using much more fuel, that would still be fine. So there's quite a lot of leniency with the sort of the logistics of that. Okay, so I'm gonna sit and have a think about how to do that, the sort of the orbit by date function, and then we'll come back in the next video and we'll implement that. So I should have this hopefully uploading overnight. I just wanted to, it's been a couple of days since I actually shot the rest of this video. I just wanted to do a quick recap of where we are, because I'm aware if I sit here and like fiddle with this anymore, I'm never going to get the video up. So yeah, in the next video I'll be getting the orbit position by like the date, and we'll carry on from there. Okay, great, thanks for watching guys, and again apologies for the sort of very the total lack of me being online for the last few months or so. Things have been pretty hectic, but yeah, let's get back on this horse, let's continue making Exodus, and I'll see you in the comments and on the Facebook group. So rock on guys, and I'll see you in the next video. Bye. Okay, so what I've done is I've adjusted the eccentricity of the target audience,